Right, hello Year 5s. If you've decided to come and look at this video, which is part 2 of Friday's Maths, it means that you've found the top section really relatively simple, and you're happy with that, and you're just going to have a peek at these challenges. Apologies, I forgot to put a challenge here as well. So all of these are challenges, and they do take a little bit of time to explain. What I want to do is, as I'm explaining, if you think, whoa, I do not get what he's just done, then don't worry. You can either carry on watching for a bit more and see if you do understand, or you can pause it there and go, you know what, that's fine, I'll wait till we understand it. When we're together again, I'll understand it, because all this will be gone over again. If you are following what I'm doing, brilliant, do try and have a go with some of the answers. Not all. I don't expect you to be able to do all of these. These would be appearing at your, some of these would be your challenges at the end of practice apply, and some of these would be your extended deepen and even your extended deepen challenges. Okay, so this is right at the end of the vault that we'd have done, the whole journey that we've done. Okay, so and it is a big jump up. So let's have a look, and I've written them down here so we can get cracking. I've also spent some time working them out myself first. So, to explain this better first, I'm not going to do this one yet, okay, because I think that first one is actually the most awkward one. So, let's have a look at these. We're still adding fractions, but you'll notice we've got mixed fractions here. And remember, we can't, if they were the same denominator, we could have a go with that. We just add the whole numbers and we add the numerators. So if that was 3 2/5, where you'd go, well, that's 4, and then you'd go over, you'd tick over, so that'd be a 5/5. That'd be all right, that's fine. But because the numerators are different, we need to sort them out. So first things first, we need to make sure they're the same type of fraction. So first of all, let's convert them. So 1 times 5. Well, it's going to be in fifths, isn't it? So oops. Yeah. So 1 times 5 is 5. Add 4 is 9. So that's going to be 9/5. This one's going to be in thirds. And then 3 times 3 is 9. Add 2 is 11. Here we go. So there's our question. 9/5 add 11/3. Now, as you can see, different denominators. And we had that up here. We had it up here, didn't we, in the last video? We had tenths and fifths. Now you've got to find your lowest common multiple. What number appears in both of these times tables? I always go with the smallest one, because it might be that one is actually in that times table. So if that was a 6, I don't want to be going 6, 12, 18 when actually 3, 6. It's in that one. So, I know. If you're really not sure, you can write out your times, just the first few. I always do the first 3 or 4. 3, 6, 9, 12, 15. Aha! There is your lowest common multiple. So, here's the bit that's a little bit different. You still do the same thing to the numerator and the denominator, but now you're going to do something different to each separate fraction. You're going to make each one have the same numerator. As soon as it's got the same denominator, you know how easy it can be. Okay, because we've just done that. How do you get 9/5 to be something 15ths? Well, in the 5s to get to 15, it's the third one, so you times by 3. You've times the bottom by 3, so you times the top by 3. So this first one, so 9 times 3 is 15. Boom, we've got that. That's that one there. 9 times 3, 9, 18, 27. There you go. This one here, how did we get the thirds to 15? Well, we've times by 5. So we times the top by 5. So 3 times 5 is 15. 11 times 5 is 55. So there's just an extra step. It's still so you can create calculations like this, but you just need to get them to the same denominator. Once you've done that, easy peasy. 55 and 27, and you've got your answer, okay? And you don't need to do anything more with that. You could look into changing it back to a mixed fraction, but at this stage you really don't need to, okay? So 55, 27, just do a quick one to check. 7, 8, should be 82, yes. So your answer would be 82 15ths for number 6. Okay? If you understood that, brilliant. Why not have a look at doing number 7? So you can pause the video there and have a go at number 7 for me, remembering it's subtraction. If you didn't understand that, then that's fine. I would suggest stopping that video there, and fantastic for doing this work. This is what we needed you to do. This was the next step, and I do not want you to worry about that. Thank you for doing the maths, and have a lovely half term. Okay? Right. This one here. So, again, we need to sort it out first. We need to get the same, the lowest common multiple for both of these. So, and we need to convert them first. So, well, first of all, it's going to be false, isn't it? So, 1 times 4 is 4, add 3 is 7. And then we're going to take away, this one's going to be ninths. Oh, that's 5 ninths. There we go. So, with this one, we need to find the lowest common multiple. So, we're looking for what we times by 4 to get an answer in the 9s. 4, 8, 12, oh, let's scribble them down. 4, 8, 12, 16, 20, 24, no. Oh, 28, oh man, miles away. 32, 36. 36 is in the 9s, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, so we're timing it by 9. So, we've got to times both of those by 9. What do we times by 9 to get to 36? 9, 18, 27, 36. We're only timing this by 4. So we've got to times them both by 4. So, if we go, I'll go down here. 9 times 4 is 36. Well, we want them both to be 36, don't we? That's why we've just found 36. There you go. So 7 times 9, that's 63. And 5 times 4, that's 20. Then all you need to do, you've got 36 to the same denominator, so you just take away these. 63 take away 20, well that's 43. Can you see that? Yes. 43, 36. And there's your answer. Okay. With these two, I'm just going to give you the answer, but and tell you the lowest common multiples. Okay. I did these earlier, and we end up with some rather large numbers. The lowest common multiple for the 7 and 12 is 84. Okay, which is quite high up in the 12 times table. So for these ones here, you'd have had to have times, well, when you've converted it, you get 16 sevenths and 11 twelfths, obviously. So if I put it like that, you can see. Okay, so you'd have to times both of those by 12 to get to 86, because you want the 7 to be 84, sorry. So you times the 7 by 84. You only need to times the 12 by 7 to get them both to 84. Okay. The top one's easy. 11 times 7 makes 77, so you get 77 84ths. This one, though, you might need a very quick calculation at the side, which I did over here. And I got 192. Add them together, you get 269 84ths. Okay, so 289 84ths. Now, it might be that you didn't know how to do that, but it might be that looking at this, you go, oh, I understand that. That is also fine, guys. Even if I'm talking to you and you're just like, I think I know what you're doing, brilliant. And it's the same with this one here. Again, we've got 12ths and 7ths. And where did I solve that one? Down here. Here we go. So this is what I did. This is what I started running out of room though. That's the problem. And then I'll get rid of that back bit as well. Otherwise, there's way too many numbers floating around. So, we had our, there we go. So converted it first of all, and I got 51 twelfths and 20 sevenths. So once again, I had to think, right, okay, 12th and the 7th. So again, it was 84. So times that by 7, times that by 7. Had to times the 7 by 12 to get to 84. So I times the 20 by 12, which gave me these. So I did 51 times 7 and checked it over here. which was 357. And I did 20 times 12. What I actually did there was 20 times 10. Oh, hang on. What did I do there? Oh, that's not right then, is it? What have I done there? 120. Oh, no, I have, yeah, sorry. I did 10 times 12, which is 120, and then doubled it, so it was 240. There you go. And then I got an answer, because now they were both 84, I can just take away the numerators. So I got 117 84ths. Okay. Now, again, if you've watched those, I did speak through that quite quick. I'm aware of the length of the video. If you understood that and you were able to do some of those, fantastic. If you listened to that and you went, I think I know what you're doing there, I would suggest pausing. Okay, you've got more than enough there if you've understood that to an extent. Okay, and brilliant, fantastic. If you do want to have a look at the very last challenge, it's only if you understood this top bit here, pretty independently, all right, or with just a little word in the ear. Because the last bit is down here. And all I'm going to do is I'm going to explain this challenge and let you do it, okay? Because it's the same concept as up here. So, this last question, this last challenge is work out the difference between these two fractions. Woo. So, where are we? There we go. Just knocked it with my knee. Obviously, I'm just going to explain this and then I'll leave you to it. Obviously, you've got two mixed fractions, but you've got two different denominators. You're going to want to sort them out, okay? So I'll do that with you. So this one's going to be sevenths, this one's going to be quarters. So it's going to be 7, 14, 21, 28. Add 5, that's going to be 33. This one, 4, 5, 6, is going to be 7/4, okay? So here are our improper fractions that we're working with. Then you've got to think about, oh, hang on a minute, these aren't the same. I still can't find the difference between these two if they're different denominators. So we need to sort those out as well. So look at the multiple. We need to find the lowest common multiple that's in the 4s and the 7s. You count up, and you should get to 28. 7, 14, 21, 28, which is by 4. 4, 8, 12, 16, 20, 24, 28, which is by 7. Okay, which then gives you these two fractions. And you can work those out, okay? But it should have 28 on the bottom on that side and 28 on the bottom over here, okay? So 7 times 4 is 28, 7 times 4 is 28, 33 times 4 is 132. I'm just looking at I calculated it on a bit of paper here earlier. 7 times 7 is 49. Once you've got that, you've got the same denominator, and actually you can find the difference now, because the two fractions you're working with are 132 28ths and 49 28ths. You should know how you find the difference. The difference just means the gap between. So if you take away 132 from 49, which you can do because you've got the same denominators, 132 take away 49, you're going to find the difference here. 2 take away 9, can't do, so let's steal. 12 take away 9 is going to be 3. 2 take away 4 you also can't do, so we're going to steal again. 12 take away 4 is 8. 83. So, you are working with, there is a difference of 83 28ths. You need to look at these, convert them, and work out which one is closer. You might also need to do some more altering of your denominators and find the lowest common multiple. If you have got onto this stage and you understand this, then I applaud you, because you have understood this through home learning with me with a piece of paper. I think that is fantastic. If you're looking at that going, whoa, 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 I totally understand and personally expect it. Okay, this was just a final big challenge to finish, okay? Please do not be annoyed if you don't understand parts of this, but if you did, absolutely fantastic and well done. And enjoy your half term, guys.